mathematical models available to us today and trying to visualize what it would have been to be there.
Created with a sea of numbers, the final image captures the drama of a cosmic encounter that would take 1 billion years to unfold. Across the campus from Donna Cox, George Francis is applying the rules of perspective to another universe, the invisible universe of mathematics.
So these are pictures of abstract ideas. I started in my drawing lots of pictures to prove my theorems. And as time went by, I found the pictures were more interesting than the theorems themselves. And so I left the theorem proving to people who can do it better, and I do illustration.
Like a musician who reads a score and hears the music in his mind, Francis can see a mathematical expression and imagine its shape.
I had seen some of the early work that George Francis had done. I said, George, I do computer graphics. You do these wonderful surfaces. Why don't we collaborate and make these images with a supercomputer?
The structures Francis draws are called topological surfaces, and mathematicians look for ways to alter their shape without changing their basic traits. Like galaxies ruled by laws of physics, these transformations follow mathematical rules. For example, creasing and cutting holes are not allowed.
So it was an interesting mathematical problem. There were these beautiful surfaces that I wanted to be able to visualize.
As an experiment, Cox and Francis picked a surface and tried to animate its changing shape.
We had no idea what the surface was going to look like once we got an image. After all the initial work of writing the code and getting the mathematics into the code, and then we saw this hourglass figure draw on the computer screen.
And I looked at the picture and I turned it upside down and said, Donna, look at this. And she said, oh my gosh. There was a rather chaste and somewhat abstract female torso, human torso.
We initially said, that looks like a goddess. That looks like a Venus figurine. And the name stuck. The Venus is a way of taking a surface and watching it really transform and eventually arrive back on itself again. What is that? There's a function that's being called such that
I think we say something is beautiful if it pleases the senses. How can something totally abstract be beautiful? Our mind simply has the same remarkable sensations when something is logically clear and finally fits together and you understand how it works. You say it's beautiful. Look at that. And there should be another hole over there, and a little further forward. There's another hole out. You can get out. Okay? I don't know whether this one has a... there's a hole.
The best part is to know that I can share information with another human being, and that together we can make something that has never been created before. Making something that's invisible, visible, is one of the greatest joys that I have.
Okay, so now we're looking at one of these new surfaces.
Working together, a mathematician and an artist have turned an abstract idea into a three-dimensional picture. But some mathematicians have ideas with higher dimensions, dimensions that cannot be seen with the eye. Renaissance perspective gave visual dimensions to abstract geometry. But in the early 1800s, a new geometry emerged that seemed impossible to draw. Then new discoveries inspired people to find ways to picture the fourth dimension.
Certainly at the end of the 19th century, we really see a major cultural shift akin to the change in worldview that comes with the discovery of perspective and Renaissance space. In contrast, however, to that visible three-dimensional space, there comes to be a great fascination with invisible realities, and certainly the discovery of the X-ray is a major event in this change. This first revelation of the interior of a hand, for example, caused an incredible reverberation in culture at this moment. The popular response is remarkable. Hundreds of articles and books, poems and songs. This is really a remarkable moment that we tend to have forgotten.
The discovery of X-rays, radio waves, electrons, and radioactivity reveals a vast spectrum of light not visible to the eye. The existence of these invisible realities inspired people to find new ways to describe them.
It is a marvelous utopian moment. The kind of feeling, this is a new world, this is a new century, we must have new languages in which to embody it. Verbal languages, visual languages, mathematical languages.
Artists are the first to explore ways to picture the invisible. Among them, Pablo Picasso.
Picasso says, "I paint things as I think them, not as I see them." Picasso does everything to avoid three-dimensionality, to create an image of shifting spaces in which figure and ground seem to merge, to suggest a higher reality that is not that of vision, but is that of conception. So as part of this turn from the visible to the invisible, the fourth dimension becomes very much identified with the notion of an infinite space.
Adventurous mathematicians struggled to depict four-dimensional space. Among them, a Frenchman named Jouffroy.
Jouffroy tries his best to give some sense of the complexity of a four-dimensional solid, creating these see-through views of shifting facets and planes, which but very much limited to the tools available to him at that moment.
As this century unfolds, mathematicians continue to explore higher dimensions. But what is needed is someone who can give three-dimensional reality to a four-dimensional shape.